There's a moment that happens every single day in America, a moment so common we barely notice it anymore. Someone reaches into a package, pulls out a chocolate chip cookie, and takes that first bite. The chocolate melts slightly on their tongue. The cookie crumbles just right. And for a few seconds, everything feels perfectly ordinary. But what if I told you that behind that single cookie lies one of the most sophisticated manufacturing operations in the food industry? What if that simple pleasure you've experienced thousands of times is actually the result of engineering precision that would make aerospace manufacturers jealous? Welcome to the world of industrial cookie production, where science, art, and technology collide at temperatures exceeding 400 degrees Fahrenheit, where robotic arms move with surgical precision, and where a single production line can produce more cookies in 1 hour than a home baker could make in an entire lifetime. This isn't your grandmother's kitchen. This is a cathedral of automation, a temple of temperature control, a fortress of food safety protocols that would seem excessive, until you understand what's actually at stake. The chocolate chip cookie factory operates in a realm most consumers never see, never think about, and certainly never question. But today, you're going behind those closed doors. You're about to discover why the cookies you buy taste identical whether you purchase them in Maine or California, why they have that exact texture every single time, and how a product that seems so simple actually requires technology that didn't exist 20 years ago. The industrial secrets hiding inside America's favorite cookie are about to be revealed, and I promise you, you'll never look at a cookie the same way again. The story of the modern chocolate chip cookie factory begins with a truth that might surprise you. The recipe itself is almost irrelevant. Yes, you heard that correctly. While home bakers obsess over butter temperatures and flour brands, industrial cookie manufacturers have discovered something far more important. Consistency isn't about ingredients, it's about physics. The perfect cookie isn't baked, it's engineered. Consider this mind-bending fact. A single high-capacity cookie production line can produce up to 2,000 cookies per minute. That's more than 33 cookies every single second. At that speed, even a temperature variation of 2 degrees Fahrenheit can result in thousands of defective products before anyone notices. This is why modern cookie factories don't just have ovens. They have thermal mapping systems that monitor heat distribution across 200 different zones simultaneously, making microscopic adjustments in real time to ensure that cookie number 1 and cookie number 2 million are absolutely identical. But here's where it gets truly fascinating. The chocolate chips themselves present an engineering challenge that sounds absurd until you think about it. Chocolate melts at approximately 90 degrees Fahrenheit, far below the 375-degree baking temperature. So how do chocolate chips survive the oven without turning into puddles? The answer involves a carefully engineered crystalline structure in the chocolate that's designed to hold its shape under extreme heat while still melting perfectly in your mouth. Food scientists spent years developing chocolate chips that could withstand industrial baking processes, and the formulation they created is actually different from regular chocolate. Those chips contain stabilizers and emulsifiers that create a higher melting point while maintaining the taste profile consumers expect. The dough itself tells an even stranger story. In a home kitchen, cookie dough sits in the refrigerator, rests on the counter, gets scooped by hand. In an industrial facility, the dough never stops moving. From the moment ingredients combine until the second cookies enter the oven, the dough is in constant motion, extruded, portioned, and deposited onto conveyor belts in a continuous flow that can last for 18 hours straight. This creates a unique problem: dough temperature. As the dough moves through the facility, friction from mixers and depositors generates heat. Too much heat, and the butter begins to separate. Too little, and the dough becomes too stiff to portion accurately. Modern factories solve this with glycol-cooled mixing bowls and temperature-controlled dough hoppers that maintain the mixture at exactly 68 degrees Fahrenheit, regardless of how long production runs. Here's something that will blow your mind. The chocolate chips aren't mixed into the dough the way you'd think. In most high-volume operations, chips are actually deposited onto the cookie after the dough has been portioned onto the conveyor belt. Why? Because mixing chips into dough creates inconsistent distribution. Some cookies get too many chips, others get too few. By using vision systems and precision depositors, Factories can ensure that every single cookie receives the exact same number of chocolate chips, placed in nearly identical positions. Some facilities have even developed systems that photograph every cookie before baking and automatically reject any that don't meet the visual standard for chip distribution. The baking process itself operates on principles that would seem like science fiction to bakers from just 30 years ago. Modern cookie ovens aren't single chambers. They're segmented tunnels with independent heating zones, each controlled by its own thermostat and air circulation system. A cookie might spend 12 minutes in the oven, but during that time, it passes through 6 different temperature zones, each optimized for a specific stage of the baking process. The first zone might be set to 320 degrees to allow the dough to spread properly. The middle zones ramp up to 400 degrees to set the structure and develop color. The final zones drop back down to 350 degrees to finish baking the interior without over-browning the exterior. This level of control creates cookies that are impossible to replicate at home, where your oven has just one temperature setting and uneven heat distribution. But perhaps the most surprising innovation in modern cookie manufacturing is something called moisture equilibration. When cookies come out of the oven, they're too crispy. The moisture content is all wrong. In a home kitchen, you just let them cool on a rack and accept whatever texture results. In a factory, cookies pass through a controlled cooling tunnel where humidity levels are precisely managed. This allows moisture to redistribute throughout the cookie, creating that perfect texture, slightly crispy on the outside, chewy in the middle, that consumers expect. The humidity in these tunnels is monitored to within 2% accuracy, and the airflow is calibrated to cool cookies at exactly the right rate. Too fast, and they crack. Too slow, and they become soggy. The scale of ingredient handling in these facilities defies comprehension. A single factory might use 40,000 pounds of flour per day. That's an entire semi-truck load. Chocolate chips arrive in 2,000-pound bulk containers called super sacks, and a busy facility might go through 15 of these every 24 hours. Sugar arrives in rail cars holding 200,000 pounds. These ingredients don't just get dumped into mixers. They flow through pneumatic conveying systems, get sifted through industrial screens to remove any foreign objects, pass through metal detectors, and are weighed with precision scales accurate to within 0.1 pounds, all before a human ever touches them. Quality control in a cookie factory operates at a level that seems almost paranoid. Every batch of dough is tested for viscosity, temperature, and moisture content. Random cookies are pulled from the line every 15 minutes and subjected to break tests, moisture analysis, and dimensional measurements. Their weight is recorded. Their diameter is measured with calipers. Their thickness is checked with micrometers. Cookies that deviate from specifications by more than 5%, even if they look and taste perfectly fine, are rejected and sent back for rework. This isn't about perfectionism. It's about statistics. When you're producing millions of cookies per week, small variations compound into massive inconsistencies unless they're caught and corrected immediately. The packaging line represents yet another technological marvel. Cookies exit the cooling tunnel and are gently transferred, often by robotic arms with soft grippers, onto packaging conveyors. These systems use vision technology to orient cookies properly, count them accurately, and detect any broken or damaged pieces before they reach the packaging machine. The packaging itself happens at speeds that seem impossible. Cookies are loaded into trays, trays are inserted into bags, bags are sealed, labeled, and date-coded, all in a continuous motion that can package 100 units per minute. The machines that do this cost more than most people's houses and require engineers with specialized training to maintain. Food safety protocols in these facilities would surprise most consumers. Workers pass through air showers before entering production areas. Ingredients are tested for pathogens. Every surface that touches food is sanitized multiple times per shift. The air itself is filtered and maintained at positive pressure to prevent contamination from entering. Temperature logs are maintained for every refrigerated space. Metal detectors and X-ray machines scan products to ensure no foreign objects have entered the production stream. These aren't suggestions. They're requirements enforced by the FDA. and facilities are audited regularly by third-party inspectors who can shut down production if standards aren't met. The raw materials that create these cookies begin their journey long before they reach the factory floor. Flour arrives from massive grain mills where wheat has been ground, sifted, and blended to exact protein specifications. Not just any flour will do. Cookie production requires flour with specific gluten content, moisture levels, and particle size distribution. Mills create custom blends for major manufacturers, and these formulations are considered trade secrets worth millions of dollars. Butter, or more commonly in industrial settings, specially formulated shortenings, arrive in liquid form, pumped directly from tanker trucks into temperature-controlled storage tanks. These fats aren't the same as what you'd buy in a grocery store. They've been engineered to have specific melting points, crystalline structures, and emulsification properties that make them ideal for high-speed mixing and consistent baking performance. The chemistry involved in creating these fats is so complex that food scientists spend entire careers studying lipid behavior in baked goods. Sugar arrives in multiple forms: granulated for sweetness and texture, liquid invert sugar for moisture retention, and sometimes corn syrup for specific functional properties. Each sugar type serves a distinct purpose in the final product, and the ratios are calculated with the precision of a pharmaceutical formula. Even the chocolate chips are custom manufactured to specifications that include not just flavor, but melt resistance, size uniformity, and even color consistency under various lighting conditions. The manufacturing process begins in mixing rooms that look more like chemical plants than kitchens. Massive planetary mixers, some with capacities exceeding 1,000 pounds of dough, combine ingredients under computer control. The mixing sequence is programmed down to the second. Dry ingredients blend first, then fats are incorporated at a specific speed for an exact duration. Finally, liquids are added in a carefully timed sequence. The mixer speed, blade configuration, and mixing time all affect the final dough structure, and these parameters are monitored by sensors that measure power consumption, temperature rise, and dough consistency in real time. Once mixed, the dough moves through a process called tempering, where it's held at a specific temperature to allow the flour to fully hydrate and the dough structure to stabilize. This might seem unnecessary, but it's actually critical. Dough that goes directly from the mixer to the depositor produces cookies with inconsistent spread and texture. The tempering period, typically 20 to 30 minutes, allows the dough to relax and reach equilibrium. The dough depositing system is where industrial cookie production truly separates from anything possible in a home kitchen. These machines use either rotary molding or wire cut technology to portion dough with incredible precision. In a wire cut system, dough is extruded through a die, and a thin wire slices through it at exact intervals, creating perfectly uniform portions that drop onto a conveyor belt. The timing is synchronized so precisely that cookies land in perfect rows, spaced exactly the same distance apart, ready for their journey through the oven. Some systems can adjust portion size on the fly, allowing the same line to produce different cookie sizes without stopping production. The conveyor system that carries cookies through the oven is itself a technological achievement. These aren't simple belts. They're stainless steel mesh bands that can withstand temperatures exceeding 500 degrees Fahrenheit while maintaining perfect tension and tracking. The mesh pattern is designed to allow air circulation around the cookies while supporting them evenly. These bands cost tens of thousands of dollars and require regular maintenance to prevent warping or breaking, which would shut down the entire line. Inside the oven tunnel, the environment is controlled with obsessive precision. Air circulation patterns are engineered to ensure even heat distribution. Steam injection systems can add moisture at specific points to control crust formation. Some ovens use infrared heating elements in addition to conventional heating to accelerate the baking process while maintaining quality. The oven's control system monitors dozens of sensors and makes continuous adjustments to maintain the programmed temperature profile, compensating for variations in ambient conditions, dough temperature, and even the thermal mass of the cookies themselves as they move through the system. As cookies exit the oven, they pass through the cooling tunnel, which is just as sophisticated as the oven itself. This isn't passive cooling. It's an active process where temperature and humidity are controlled to achieve specific results. The cooling rate affects final texture, moisture content, and even shelf life. Cool too quickly, and thermal shock can cause cookies to crack. Cool too slowly, and they continue cooking from residual heat, becoming overbaked. The cooling tunnel uses a combination of ambient air, chilled air, and humidity control to bring cookies from 200 degrees Fahrenheit down to room temperature over a period of 10 to 15 minutes, following a carefully engineered cooling curve. After cooling, cookies enter the packaging area, where they're handled with surprising gentleness despite the industrial scale. Modern packaging systems use servo-controlled robots that can adjust their grip strength based on the product being handled. Vision systems inspect each cookie for defects, cracks, burns, chips that migrated to the edge, or any other imperfection that would make it unacceptable for retail sale. Rejected cookies are diverted to a separate line where they're broken up and either sold as ingredients for other products or donated to food banks. The packaging materials themselves are engineered specifically for cookies. The films and trays aren't generic. They're designed to provide the right balance of oxygen barrier properties, moisture protection, and mechanical strength. Some packages include modified atmosphere packaging, where the air inside is replaced with nitrogen to extend shelf life. The sealing process uses heat and pressure calibrated to create a hermetic seal without damaging the cookies or the package graphics. Throughout the entire process, from ingredient receiving to finished product palletizing, every step is documented. Modern factories use manufacturing execution systems that track every batch, every ingredient lot, every process parameter, and every quality check. This traceability means that if a problem is discovered, even weeks after production, the factory can identify exactly which ingredients were used, what conditions existed during production, and where every package from that batch was shipped. This level of documentation isn't optional. It's required by food safety regulations and is essential for managing recalls if they become necessary. The facility itself operates 24 hours a day, often running 3 shifts with only brief shutdowns for cleaning and maintenance. The production schedule is optimized by sophisticated software that balances customer orders, ingredient availability, and line capacity to maximize efficiency. Changeovers between different cookie varieties are choreographed like a pit stop in professional racing. Teams of workers execute a planned sequence of steps to switch recipes, adjust equipment settings, and verify quality, all in less than 30 minutes. Energy management in these facilities represents a significant operational challenge. Ovens consume enormous amounts of natural gas or electricity, and cooling systems require substantial refrigeration capacity. Modern factories invest in heat recovery systems that capture waste heat from ovens and use it to preheat incoming air or water, reducing overall energy consumption. Some facilities have even installed solar panels or cogeneration systems to reduce their environmental footprint and energy costs. The workforce in a modern cookie factory is far more technical than you might imagine. Yes, there are production workers who monitor lines and perform manual tasks, but there are also automation technicians who maintain the complex machinery, food scientists who develop and optimize recipes, quality assurance specialists who ensure compliance with standards, and engineers who continuously improve processes. These aren't minimum wage jobs. They're skilled positions that require training, certification, and ongoing education. So the next time you open a package of chocolate chip cookies and they taste exactly like you remember, exactly like you expect, understand that this consistency isn't an accident. It's the result of millions of dollars in equipment, decades of process development, and the daily work of hundreds of people who take pride in producing a product that seems simple but is actually the culmination of food science, engineering, and manufacturing excellence operating in perfect harmony. If you found the precision and technology behind cookie production fascinating, you absolutely need to see what happens inside an ice cream factory, where liquid milk transforms into perfectly frozen scoops in a process that defies physics, operates at temperatures 50 degrees below zero, and involves machinery that can produce 400 gallons per hour while incorporating mix-ins with robotic precision. That video just appeared on your screen, and trust me, the cryogenic engineering and the science of preventing ice crystals will blow your mind even more than cookies did. Don't forget to subscribe to this channel so you never miss another behind-the-scenes look at the factories that produce the food you eat every day. And here's a question for you. After learning about the incredible technology in cookie production, what surprised you most? The precision of the chocolate chip placement, the complexity of the oven zones, or the fact that cookies are actually engineered rather than just baked? Drop your answer in the comments below. I read every single one, and your responses help me decide which factories to explore next. Thanks for watching, and I'll see you in the next episode.